Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on oil network modeling using GAP software. It's a very interesting and powerful software for network modeling. Okay, now in this video, we will continue further and we will analyze the snapshots. Maybe we can focus only on well 1A for now. I'm going to uncheck everything except well 1A. All right, so from the plot, we can see that well 1A will die in late 2016 or early 2017. As you can see here, we have good production rate here, but suddenly it drops. The well ceases to flow. We will analyze this event using snapshots to understand why this actually happens. Whenever using the snapshots, it is always recommended to analyze the snapshot just before the event, as well as the snapshots of when the event occurs. This will enable us to grasp which conditions have changed as time advances. Okay, so to view a snapshot, I'm going to close it here. We go to prediction. Now let's find reload prediction snapshot. Here, reload prediction snapshot. Click on that. To perform a snapshot reload, the current file must be saved. OK to proceed. OK. All right, and then we select the date just before well 1A dies. Maybe we can check it once again. Plot nodes, none, and well 1A, plot. And then let's find oil rate. Okay, so May 1st, 2017. Maybe we can maximize. Okay. May 1st, 2017. I'm going to go there, reload. May 1st, this. All right, and then click on OK. New bitmap interface, and then May 1st, 2017. Prediction snapshot loaded. Okay, so to analyze well 1A in more detail, let's double click on this to find the system summary screen. And then we go to the calculate option. Okay, so now it's the calculate here. So you select summary and then calculate. Now we have VLP IPR calculation. All right, and then we click on calculate here. Or first, after you click on this calculate button, we go to initialize from solver results. All right, and then here we get the water cut as well as the GOR and the manifold pressure. And then we just click on calculate. Okay, so the computation, completed. So we have the flowing bottom hole pressure, flowing wellhead temperature, liquid rate, flowing wellhead temperature, C factor, and so on and so forth. And then we click on the plot solution. So we get here. So we get the VLP and IPR. Right? The green curve is of course the VLP, the black curve is of course the IPR. And very clearly you can see from the plot, it is very clear that the well is about to die. You see here. Do we get intersection? Still, there is a little touch between the VLP and the IPR. But clearly the well is, almost die. It's about to die. Okay, I'm going to click on that. So it is also possible to use the VLP IPR calculation to understand how sensitive the well is to changing conditions. For example, if the manifold pressure was increased, say, to 430, right, and the calculation is repeated, it is possible to confirm that the well will stop flowing. We can see here. So the manifold pressure is 406. If you just increase the manifold pressure, we can predict that the well will die. All right, so we can click on this. let's just change to 430, let's say, and then recalculate. No solution. If you plot, then there is no intersection between the VLP and the IPR. All right, and of course, at this condition, there is no flow, the well is dry. Interesting. Initialize from solver results. Once again, recalculate, plot solution, there you go. So at this time step, the well is about to die, and thus, after this time step, the well ceases to flow. And the GOR and water cut can also be modified to understand how the well would respond to these, parameters. So you can still change the GOR. If the GOR decreases, all right, now then the fluid will become heavier rather than lighter. And of course, most likely the well will die, just like you increase the manifold pressure. Okay? So if this procedure is repeated for the next 2 consecutive time steps, then we will observe that there is very little change in the reservoir pressure, water cut, and GOR for well 1A. However, the slight changes in wellhead pressure, which are due to the rates being produced from each well in the network as the prediction proceeds, coupled with well 1A sensitivity to the wellhead pressure, is what leads to the well become, dying. All right, so at this time step, at this condition, the combination of the water cut, GOR, and manifold pressure, also the reservoir pressure, the combination makes the well very sensitive to dying. All right, and of course you can exercise, you can play with this. So having a snapshot at a certain time step, is very, very, very useful for our sensitivity study, for our detailed study. All right, so what else? So now with this, we can answer one of the biggest question for our case. So the pressure of reservoir A will drop below the bubble point pressure, and well 1A and 2A will die just within 6 years of production. And we utilize very good feature like Snapshot so that we can dig into a specific particular time step to know how sensitive our well is and which parameter can lead the well to dying. Okay, so I think we can stop it here. In the next video, we'll try to learn more about oil network modeling, and hopefully we can explore more features in the gap. All right, so until then, thank you and see you.